Today we will going to learn the difference between a rational and an irrational number. Rational and irrational. Rational number can be expressed in P by Q form, where P and Q both are integers. Q is also integer and P is also integer, but the denominator, that is Q, is not equal to 0. In case of irrational number, it cannot be expressed or it cannot be written in the form of P by Q. It cannot be written. For example, come to the rational number, we are taking some example. If we come to the example of rational number, if I have written 7, then we can say 7 is rational. Why? Because it can also be written as 7 by 1, where 7 is integer and 1 is also integer. Let us take one more example. Minus 2 by 3. Minus 2 is integer and 3 is also integer. Come to the example of irrational number. Since we have understood that it cannot be written in the form of P by Q, so we cannot write it as 7 by 1 or minus 2 by 3. So for easy understanding, we can say any number in the form of square root form. Suppose root 2, root 3, root 5, root 7, etc. All the numbers that we observe in under root form, in square root form, in radical form, they are called as irrational numbers. Now come to their decimal form. Rational number has two types of decimal form. Number first is terminating. Terminating means the digit after the decimal came to an end. Suppose we are taking a rational number 7 by 2. If we try to convert it in decimal form, let us divide it. We have to divide 7 by 2. 2, 3, 6. After subtracting, we are getting remainder 1. Taking the decimal, we get 0. 2 5s are 10. Here we are observing that there is no remainder left. The answer is 3.5. The digit after 0.5 is not continuing, or we can say the digit after decimal came to an end. So we will say 3.5 or 3.5 is terminating decimal expansion of rational number. The second type of decimal form for rational number is non-terminating recurring. Non-terminating recurring. Recurring means repeated. Suppose we have to divide 7 by 3. If we try to divide 7 by 3, let us try it out. 2 times we get 6. After dividing 1, we get as a remainder. Take the decimal, 0, 339. Again we get the remainder 0. Since we have decimal, so we are taking 0. Again 3 times we will get 9. So again remainder 1. So we will observe that the remainder is repeated and every time we are getting 1 as the remainder. So the digit after the decimal, it is repeated. it is repeated and it do not came to an end. Since it do not came to an end, so we will say it is non-terminating. And since it is repeated, the digit 3, we are observing the digit 3 is always repeating, so we will say it is recurring. So such type of decimal expansion are called non-terminating, recurring or repeated decimal form. So we had learned rational number has two type of decimal form, terminating and non-terminating recurring decimal form. Now come to the decimal form of irrational number. Irrational number has only one type of decimal form, that is non-terminating, non-recurring. Non-recurring means non-repeated decimal form. Let us take the example pi. You all know what is pi. The value of pi is 22/7. If we try to change it in decimal form, let us try to divide 22/7. What we will going to observe, let us see. This will 7 3 21. 3 times we are getting 21. 1 as remainder. Decimal, take 0 1 time. Now we have the remainder 3. Since we have decimal, we have taken 0. Now 4 times. Again we are getting 2 as remainder. Decimal we have, so let us take 0 2 times. 6 we get, again take 0 8 times. So what we are observing over here, we are observing that every time we are getting the remainder, but the remainder is not repeated. First we get 1 as remainder, then 3 as remainder, then 2 as remainder, then 6 as remainder. So what we are observing over here, the digits after the decimals do not came to an end, and they are also not repeated. So 3 decimal 1 4 2 8 and so on. So such type of decimal expansion are called non-terminating, because the digit after the decimal do not came to an end, and since the digits are not repeating, so they are called non-recurring. So it is considered as non-terminating, non-recurring decimal form. So such type of decimal form are considered as irrational number. Now 2 points you have to note. Some points that you have to note. In the starting we observed that some points to be noted. We learned that irrational numbers are in under root form. So let us consider some natural number 1 2 3 4. Let us check whether every number in root form are irrational or not. So we are taking some natural number 1 2 3 4 5 6 7 8. Let us find their square root. Square root of 1, square root of 2, of 3 4 5 6 7 8. We all know how to find the square root. The factor of 1 can be written as 1 into 1. Square root means we have to find the pair of numbers. So we have the pair of 1, so 1 will came out of the root. So 1, now 1 came out of the square root form, so it will be now considered as rational number. Why? Because now it don't have any under root form. It is now p by q form. The numerator is 1 and the denominator is also 1. We can write it as 1 by 1. Come to the next, root 2. The factors of 2 are not possible, so no pair is formed, so it is irrational number. Come to the next, 3. The factor of 3 is also not possible, so again it will remain within the under root, so it is irrational. Root 4. the factor of 4 is possible, we can write it as 2 into 2. Now we get the pair of 2. So 2 will came out and its under root form, its square root form is now we are observing is removed. So it is now rational. Root 5, it does not have any factors, so it will remain within the root form, it is irrational. Root 6, it has factor 2 and 3, but both the factors are different, no pair is formed. As we observed in case of 4, we have the same 2 into 2, but in case of 6 we have different factor 2 and 3, so no pair is forming, so they will remain within the square root form, so it is again irrational. The factor of root 7 is also not possible, so it is irrational. Come to 8. 8 can be written as 2 into 2 into 2. Now we have to find the pair. We are having the pair of 2 one time, but 1 2 is left alone. So out of this pair, 1 2 came out of the square root and the left one will remain within the square root form. So again we are observing this under root form is there, so it will again irrational number. So you have to note that every number in square root form are not rational or irrational. If after calculation they came out, after pairing they came out of the square root form, then they will change into rational, and if they do not, then they are considered as irrational. This point you have to note. Thank you.